Hello, welcome to Automat Live Coding. Today we are going to continue the stuff that we started during the last stream. We didn't quite finish it. I can show you what we did during the last stream. It was on shader toy. Look this up. A sec. Why does shader toy keep logging me out? Okay, so last stream we made this, not this, not this, not this, this one. This is a visual effect. The stuff that you can see here, you can see two circles, like you can actually see several circles. One of them is my eye tracker. Ignore this. This is where I'm looking. This is a shader. The shader only sees those two circles, the red one and the white one. You know, small white one. And what this shader does is it tries to compute a displacement which will take this point and stretch it all the way to this red point. By tweaking the parameters of this thingy, we can get all sorts of effects. So first of all, I will disable the waviness. And enter, something like that. Okay, so now it's not moving. So now the displacement is doing exactly what I said. It's taking this point and stretching it all the way here, but without creating any discontinuities in the image. So it's a very fun stretch effect, and we're going to use this to simulate an object being sucked into another object. And this thing, like, we could make this even more interesting if we added a spiral transform. So we are doing this in a linear space. So this is just, you know, this point is just pulled in. We could also do this in a polar coordinate system where we would pull this point in along the, you know, radial axis, but along the other axis we would just stretch it, you know, around. So it could create a sort of a spiral sucking in animation. But this spiral is not very readable, so I think this sort of direct stretching is going to be better for this situation that we need to handle. And you can see how it looks now. I think something like 0.9 is good. The 0.9 decides what's the maximum stretch. When it's 1, you know, we can stretch infinitely. If it's smaller, we can only stretch a little bit. And for example, make it so that this lady is going to be sucked in. Maybe I should hold her somewhere here by the shoes. Yeah, now she's being sucked in. So this is our shader. You can also see how the mask is looking. It's looking like an ellipse.
Meister Chica says,
Oh!
Hey. Yeah, so this is the plan for today. But before we jump into this, I wanted to mention something else. Because we're working on Automat. So what is Automat? Like, I haven't even kind of introduced this. Automat is a game automation app. It's an app where you can just record some repeatable action and repeat it in the game. And it has some facilities to do more than that. So it can capture screenshots, it can do text recognition, you can script some simple logic in this. But there is one type of game which I'm automating, I think, the most. So this is, for example, like one funny object. I'm not going to explain what it does because the explanation is going to be long. Most of the time you use this thing. So I just recorded a macro. That thing, that squiggle, this is my mouse movement. I can play this back and you can see it moves by itself. And this. See, a handler here. It's making loops. It's going to play forever. That's false. Nothing's forever. There are no infinite loops. At some point, somebody hits Ctrl-C and, execution stops. So that loop was just 2 loops long. Anyway, so Automat is very good at this kind of automation where you have to repeat the same action over and over. It has some very, very efficient computational mechanisms that I'm not going to explain, like I said, but it's still missing something which I actually enjoy the most, and this is automating games which have this combinatorial aspect. Like, for instance, in Factorio, you have lots of ways to arrange your factory. People would say you cannot automate Factorio. You absolutely can. It's just you automate a different part of this game. You automate the design aspect. And there's just so many places, like even not only in games, where I really enjoy this kind of combinatorial optimization. It's a very fun sport, I would say, but there are absolutely no tools to do this efficiently. Always when I have to do this, I have to reach for C and C++. And this is such a pity. I think there should be some better tools to do this kind of recreational combinatorial optimization. I don't know how to call this. It's kind of like... I don't think there is much reason to do this. Oh, I mean, there is. Optimization is useful.
In the time I was last on your stream, approximately 7,400 babies were both born and conceived.
Interesting. Was it last Friday? You nerd sniped me, come on. How can you do this? I'm not going to think about this. I have to stop thinking about this. Okay. Anyway, combinatorial optimization. I would love to put some tools for doing this efficiently. But the thing about this is that there are several techniques that are used here. The most typical one is to just iterate over some values, construct some states, and then score them. And the way that you construct new states and score them, that you do this search, it always follows some kind of path. And this path can be either, it's always a loop, some sort of loop, where you iterate over some states. Sometimes you can actually make this exploit dynamic programming. Dynamic programming is kind of like a subtype of search, where you just search in a very systematic way and reuse previous results. But there are like so many different search strategies. And I think if we could somehow capture this into a set of reusable, abstractions, visual primitives, that could also execute natively at a very high speed, at the level of machine code. This is our machine code implementation. This could be really something. This could be really something interesting.
Trying for that.
Oh, that was a long time ago. I was skipping some streams, so... even the thought of skipping this stream went through my head, because this morning I got Steam Machine. It's like sitting at my table below, but I actually pondered, do I want to play on the Steam Machine? And I do want to play on the Steam Machine. But I kind of want to do this more, so here we are. Yeah, I only skip streams when I'm out of town. I think the stuff that we are doing is kind of very interesting.
You did not partake in that, I assume?
Oh no, it's connected, but it's not even updated yet. I still need to set it up. Okay, it will be a tangent, but I think it could be an interesting tangent. I was mentioning optimization. There is a very specific type of optimization that... Okay, I can't really show this because it's only in Polish. There is a little bit of vibe coding, a little bit of optimization here. So in music, right? In music, there is this thing called music theory. Music theory, if you want to know, it's somewhere between mathematics and physics and numerology. So music theory, there is a lot of esotericism there. Like people come up with some fancy, absolutely crazy terms for doing simple things. Like I was coding some... If I find this, okay, it's in another file. Blah, blah, blah. Oh yes. The people who come up with music theory, they invent a very complex way of describing something which is essentially very simple. Like when you have notes, they form like a geometric sequence where each node plays at some frequency and the next one plays at a slightly higher frequency and so on and so on and so on. It's a very old system developed in, I don't know, 18th century or so. And it's only getting more complicated since then. Anyway, if you work on computers, a much better way to describe those nodes is by numbers. So you can assign different numbers to different nodes, and this way you can talk about them, and you can also do all sorts of math and optimization based on them. So I actually spent the whole weekend optimizing guitar layouts. I now have a system that basically I can... so here I can kind of see how a layout looks, and here I can optimize it. I can find fingerings or ways to play this layout. Yeah. So I kind of destroyed my guitar because of this. Literally, it broke. But in the process of breaking this guitar, I created a very cool layout, tuning for a guitar. A tuning for a guitar is kind of like a keyboard layout. Most of the time you type in QWERTY, and this is kind of the same with guitar. The layout on the guitar doesn't make much sense. It kind of makes sense, but kind of complex. It makes sense for playing chords. It's a very efficient layout for playing chords if you do not have a capo. But if you have a capo and you don't want to play chords, it stops being a very optimal layout. Just playing with different fun layouts. And this layout, is the one that broke my guitar. Like, I have a kind of string that broke. But the stuff that survived, it's kind of working very nicely. Yeah, so I can show you how it plays. It sounds weird. Okay, there was a weird noise, but okay. Let me reset something. Yeah, now you can hear guitar as a single note. This is G3, or I don't know, actually I have no idea which note it is. It's 50. This note is probably 50. Sorry. This one. Very common from like music. Every guitar tuning has this note. And I retuned this guitar to maximize a very specific type of chord called power chord. Power tuning, as this is this one. So whatever you play on this guitar, it will sound heavy metal. I pull strings and It's like, and there is even no amplifier built in, because most of the time, to get this kind of sound, you need an amplifier that will basically cheat a little bit. It will bump some, frequencies and lower some other frequencies. But if you put this tuning on an acoustic guitar, the acoustic guitar should sound kind of rock-like, I think. This is just open chord. It's like very deep power chord with lots of harmonics. I can play different chords. Play very high power chords. Yeah, I love this kind of stuff. I barely slept through the weekend because I was playing with this, with changing guitar tunings and finding good, interesting ones. Like, what's the best layout for blues? What's the best layout for pentatonic scales? Or like, those are just weird terms that that music theory esoterics came up with. Actually, this is a good thing, good term. Maybe you shouldn't call this music theory, maybe you should call this music esotericism. Or music numerology. Oh yes, music numerology, it's even better. Anyway, I was thinking how I could bring something like this over into Automat, this kind of optimization. Because the way that this system works, this optimization works, is that I iterate over all possible tunings of a guitar. I just search through all of them, and for each of them, I compute some scores. I basically ask, hey, is this tuning good in this specific use case? And each specific use case means that I need to simulate somebody playing on this tuning. So I need to, okay, I have a tuning, so I search through all of the strings, I jump to this callback. So this scorer, it does exactly this. It tries to play through a specific guitar tuning, it tries to play a lot of chords, it tries to play the scales, so do, re, mi, fa, sol, la. And to do this, it needs to find hand layouts that will work. And this finding hand layouts, it's probably the hardest part of this whole thing, and it has to be done thousands of times. 7 to the power of 50. Yeah, 16,000 times. So not that bad. But still, we cannot do something, billions of times here, because then it would take like really long time. We need to wrap this scoring in about million or a couple million operations, instructions. Yeah, so the structure of this is what I'm interested in. Look, we have loops where we iterate over some properties and we progressively fill the state. We fill the state and then we start scoring. And this scoring, it also does some iteration, but it also builds some internal state. And it's kind of built in a very stack-like fashion. And then when it finds good ones, it kind of decides, okay, let's lock onto this value, and it returns up. And then we go into another part of the scoring. Again, we have another loop. Here we check for each musical scale, how good this scale plays in this layout. And this score scale is actually the hairiest function of all of this, because this is the actual dynamic programming part. This is the part where internal loops reuse results of the previous loops. We actually have some caching, some state maintained across those loops. And I think a good general purpose optimizer, if we ever make Automat capable of doing this kind of optimization, it needs to be able to capture this sort of different kinds of searching through this space. Because the dynamic programming, it's kind of like searching through a very complex space, like a very multi-dimensional space, where each dimension kind of depends on the previous ones. Yeah, it's a way of mapping very complex problems into this kind of searchable array-like structure. So this dynamic programming is also very similar to those others, but I'm still thinking how to visualize this properly, because there is a very interesting structure here, and I think C and programming languages are very bad at capturing this searching problem. I think there is a better representation for searching, and I think if we can marry searching, a good representation for searching, with a very efficient, scoring and generation with, very low-level instructions, this whole system could be a very good optimization machine. And this is just one optimization problem, this music tuning. There are other types of, optimization problem. If I have plenty of them on my desktop, but let me find some of them. Here I had a game, Buildmatic. This is another tiny program which does the same kind of optimization. This is something I've done, I don't know, 2 years ago or something. Here I have some folder called covering points. I have no idea what this does, but it sounds like some kind of optimization. Oh yeah, this was actually for Automat. This was for the timeline visualization system. It's because once you develop something like this, they tend to run very fast. So they tend to solve problems in a very interesting, very efficient way. Yeah. This directory, this one contains my chording keyboard, this keyboard. It also has a keyboard layout that had to be optimized, so it also required the same kind of optimization essentially. Yeah, so this is something that I do all the time, and very few people are interested in this. And I think more people would be interested in this if there were better tools for this. Because normally to do this you need to know how to program. And programming is kind of bad at this. It's really incredibly clumsy to program search as this kind of C-like statements. I implemented it like that as a bunch of nested for loops because this is efficient. But you need to know that this structure is efficient. Like some other person or some kind of stochastic parrot, they would probably implement it by having some depth argument and then recursive function. Recursive function is not necessarily the optimizer cannot often see through recursive function, so it's very dangerous. It's easier to do it like that. But I also had to put auto here because I kind of know how C++ works, and C++ has lots of footguns. If I put a very concrete type here, like function, std function, something, then it's going to tank the performance. So there's so many footguns in this language. It's really terrible at doing this. So you need to know this very well to do this kind of optimization, and it's also very rigid. Because if I want to change the way I do this search, because sometimes maybe the choice of the last string could be, pushed deeper into this optimization problem. Now that would be an interesting thing to do. But in C++, it's so hard to do this. because this dimension, it's kind of locked to the syntax, and syntax requires retyping, a lot of function signatures, and it's very error prone. So I think a better visual representation of this sort of nested search structure.
I have a question.
I think something like this could be very nice.
So you're saying you might as well learn Rust if you're going to have a headache anyways?
Yeah, and Rust is exactly kind of like that. Rust, it's even more rigid because of the lifetime annotations. Fundamentally the language is the same, but because you have lifetime annotations on every type, you also need to adjust those lifetimes. So every tiny change in code requires lifetime adjustments. It's like having to solve Sudoku after, moving a chair. I just want to move the chair, the compiler should solve the Sudoku for me. Anyway, in Rust you would do this without lifetime annotations. In Rust you would use just arrays and indexes, and you would just have panics because of you escaped the range of the available values. Anyway, I think there could be a better syntax for doing this, and I'm thinking that I need to think about this.
If I gave you the source code of my cheat tool, would you mind sharing some of your knowledge in regards of prevention and or detection of the used tool to cheat?
Says.
Callbacks in Rust can be a headache because of lifetimes, especially if you need to put them somewhere.
True. This is the epitome of unsafety, this kind of thing. I am taking a reference to something that's on the stack, because this callback, it's a lambda that's on the stack. That is very efficient. And compiler will actually just inline all of this, so it's not going to even... It's just a way to reduce the nesting level, really, this callback thing.
Meister Chica says.
Callbacks in C are so easy.
By the way, it sounds interesting. You can share your tool. We can take a look. I will probably keep the I can tell you about some low-hanging fruits that everybody knows about.
It's just void pointer to address a function.
The problem is when this address of the function lives below your stack frame on the stack, then you should worry. Below, I mean, it was allocated in a nested function. And this is essentially what lifetime annotations boil down to. They basically prevent you from passing, references to stack values up the stack. And some other things. This is like 90% of it.
Ian says.
I wanted to get rid of ref counting a struct, holding a callback in Rust the other day. Because it was a hot code path.
Yeah. Go on.
After spending 3 days on it, threading the lifetime through like 10 layers, I regret everything.
Yes. I can give you one cheat code that will make you love Rust. Absolutely love Rust.
I will not use static.
this is the best language, in my opinion, which is a kind of like a trade-off between C and Rust. This is called unsafe Rust. You just put unsafe at the top level, and the compiler just, okay, it just accepts whatever you throw at it. You can use row pointers, no annotations at all. It's very fun. Like, Rust becomes a very fun programming language if you just embrace the unsafety. There's this global annotation that you can put that will make, basically the whole module unsafe. I think it's this one. I remember there was something that you can put at the top level, even of the file.
Meister Chica says.
Unsafe is basically O4 for CC, if it existed.
Yeah, I think you can just put everything in this unsafe block and everything in unsafe functions. This makes Rust so much nicer to work with. Type can be unsafe? Of course. Maybe there is a way to match the whole module as unsafe, but they are probably trying to hide this. There is some kind of shame in Rust about unsafety, and I think it's bad. They should be proud of it. Like, the whole point, it's not really unsafe, it's a misnomer. Unsafe, really what it means, it's not statically checked, unchecked. It doesn't really mean it's unsafe, it just means the compiler couldn't verify it automatically. So it's a very nasty word, it's a dirty word, but it's not a bad thing, if you think about this. Just a piece of code that wasn't analyzed, maybe it's just a very complex mathematical, it has some elegant mathematical properties that are actually sound, but just the compiler cannot check them because it's too stupid. So unsafe doesn't really mean unsafe. Unsafe means compilers too stupid to understand it.
May I give you cheat code for CC?
I am listening.
Some assembly required.
Now I'm listening.
It will be more taught apperment than straight-up cheat code.
Okay.
Imagine you are developing new compression algorithm.
I'm imagining it. Vividly. Yes, I can taste it now.
Meister Chica says.
And you want allow compression of up to 64 bytes at the time.
Sounds like something chess related, but okay, continue. By the way, I'm adding some chromatic aberration right now. It's very cheap to do in a shader. This is how you do it. That's too much. Still too much. You can see now the pool is even stretching the colors.
And developed it, and it was major success, and everybody is using it. And now comes this new chip, well, call it SPU, Simple Processing Unit. It has 4 8-byte wide registers. And you want to optimize your algorithm, but you don't want complicate life for other people while still allowing for 64-byte compression in single pass.
It compresses most PhD students' 100-page thesis papers to the string. Trash. Lossless compression.
Meister Chica says.
You are correct.
I was checking different types of chromatic aberration, but I think the standard one looks best.
So what do you do if you know you can overflow argument passed to the called function?
I'm not sure I'm following this step right here that you just made. We can overflow argument past a function. Save this. Let's put this in the assets directory. Need to introduce some variables. That's a longish.
Says.
I'm not getting it either. I have decided it's because I didn't have fish for breakfast. Carb debuff.
Meister Chica says.
What I mean is you can supply argument of that is twice as wide as register.
So there are like 3 options. You pass pointers. You just keep the stuff on the stack or some global space. You can introduce kind of memory, like virtual registers, just global variables. So pass pointers introduce well-known memory locations, or you can try to just squeeze a value into registers. Or, yeah, that's it basically. I mean, you cannot squeeze the value in multiple registers here because you do not have enough registers, that's the problem. I don't know what else. You said this is a compression algorithm, so maybe it's enough to compress the result or something like that. You know, the decompression could decompress into memory. I don't know.
Keep in mind that new chip can work only at 32 bytes at single time, but you need to process 64 door.
So the problem is not about passing results or data in, the problem is having working set that covers 64 bytes. You're talking about registers as if there was no option to use memory. Does this simple processing unit have no memory? Usually a CPU uses registers just to as a working memory kind of. You actually store longer-ish piece of data externally. But yeah, I guess that would cause a lot of thrashing because you would have to store the data in system memory.
It has memory.
Yeah. So I guess the best plan is to just write a new algorithm which is optimized to 32 bytes at the time. Something that doesn't, constantly have to reach into memory. Yeah, just redesign whole algorithm, assuming, the size, the number of registers and size of registers that the computer provides. This should be... Okay, I need to think about how to put this shader in the Automat's model.
Yes, you redesign it to 32 bytes, but your code will need to call some assembly.
Okay, that is not a problem.
So you keep the code you have as is, and you make special case for spew chip, where you write compressor in its native assembly for squeeze everything out of it, and then you simply call that procedure in your algorithm.
Yeah. Or I think there would be a little bit, possibly, more attention. I would pay probably a little bit more attention to the linker, because it's possible to configure this code so that when the linker loads it, it will just make sure it loads the right code right away. So, the SPU doesn't have any 64-byte related algorithm, and vice versa. Like the 64-byte CPUs don't have 32-byte code. That may be tangential to what you're talking about, though. Actually, this is a fun idea. Maybe we should vibe code a shader toy within Automat. I would like it to function together with official shader toy, though. Anyway. Then we need to I'm going to need the Okay, I am also going to need the I need to somehow scale this. Mask is an ellipse.
URL.
Exe project, the famous one for being compromised.
Sir 32 Battery 6 dot S.
I think there is a dedicated instruction for CRC32 nowadays. Even, do we have it here? Okay, I think I excluded this. I don't remember why. Maybe my CPU didn't have it. It should be somewhere here. It's not here.
Dear Rackets of X2.
Maybe it was taking some funny registers, because when I construct a list of instructions, I filter by the registers, because I have icons for only some of them. Only 10 icons, I think. 10 or is more icons. And they are just not shown here. That's a nice gadget. Yeah, I guess this is the easiest way to read the instruction pointer. There's an if def for this. Checks for peak. Wow, this is optimized assembly. Yeah, nothing crazy really. So what's special about this function? I don't know what to look at. The only thing that draws my attention are actually the boilerplate around it.
Line 229.
And this is, so x86 has this memory addressing scheme where you can specify multipliers. You can specify up to 4 bytes of offset and 2 registers. One of them is called the base, the other is called the index. The index can be multiplied by 1, 2, like 0, 1, 2, 4, or 8, I think.
Code generated by optimizing compiler for 386 wastes 70 instructions.
Yeah, memory expressions and ATCs are like a hidden superpower. You can basically every instruction has the ability to loop over stuff. Yeah, a little bit. Like the size of the data cannot be larger than, I think, 8 bytes.
In the same of block of code. And that is real-life proof of my cheat code for CC.
I'm still trying to understand what it's doing. EBP has... Oh, this is EBX and EBP, okay. I was thinking this is the same variable, okay. So this is the address in memory, this is the index, this is the... also, what is this? This is maybe some name of the table, maybe. There are probably like 3 different tables here, or like even more. Oh, so it's actually using this memory directly. It's not actually loading this into a register. Yes, it's not. Ah. This is nice. This is really nice. I still do not understand why those offsets are different. Those offsets, they are used to identify different variables typically, or like different arrays here. Or maybe I am mixing the bits. Maybe this is some kind of byte swapped variable. That would actually make more sense. So we do some operation on this C, offset 8 or 16, yeah. Okay.
Wait moval. Move. Low packed data.
URL.
This is closest I can find that still exists.
Okay. So this is some kind of slight historic instruction. Nice. But yeah. If you know some of the kind of gadgets that exist in assembly, compilers rarely make use of them. They do, but they cannot really abuse them the way a programmer would. Other thing.
Or could it be 4 wide move?
No, this 4 is definitely multiplier for the size. Maybe this was part of some loop or something. Not sure. Be right back.
Tiered move is 1, and move do is 2 wide, and move defaults to 4 wide, and move key is 8 wide.
URL.
Reference material .bull.
You found some manual. Yeah, array base. Why is the base different every time? So strange. You use this to identify different variables within some struct. There are, if I remember correctly, there are like 2 versions of this. Modern CPUs also have something like this, but they can do this with every instruction, basically, this kind of syntax. Every memory expression can have this sort of addressing. It has a name. I do not remember what's the name of this. There is a short variant where you can specify this base address as as a single byte, and there is a version which has 4 bytes. Those are two very fun I think it's called RM expression or something like this.
Move struck by a z-index of 512 wide member is computational cheat code when you can use 512 wide math.
Actually, yeah. But the biggest limitation in those expressions is that the multiplier cannot be whatever. You only have a choice of 8. I think 8 is the largest you can use. So the values that you store in memory, unfortunately, it cannot be used for this super cheap iteration where you just increment and look up using the index variable as the multiplied offset. By the way, there is a design in Automat how to visualize those memory expressions. It's in art, sources, assembler. Where was this? Maybe. Yeah, Inkscape, come on. Oh yes, Inkscape opened within Automat. Great. Great. How do we use this now?
Beta 2 here is a checkered pattern or just a chessboard?
It's neither. Currently, it's a flag that looks like a chessboard. It's a striped flag that wraps many times around the pole. So it starts here, it goes like this, and it wraps around, it goes behind, and it comes back in front. Because it's a long list of flags, so you can have many flags here. That's the point. This is why this guy is holding a flag. This is my stack pointer. Many things will happen if I change this pointer. I think it will. It will work. It will work. But yeah, this is the only way that I can access the stack. If I delete this, I cannot access stack in Automat's assembly anymore.
So you are saying, are affiliated with Croatia?
Here? No. This is it. Is there a hand tool somewhere here? No. I need to move like that. Like, oh, there is space. Yes, yes, this is the plan. So in Automat, we have this helix of cards, right? This is the helix of cards. You can see it here. And below it, there is a bunch of filters. Those filters will go away. But this section here, I had a much better design actually. Much better. Let me find a better one. This one? No. Maybe it's in Krita? No. Let me select. Yeah. The idea is that you can select two registers. The first one can have a multiplier, one of 8 values, and add some fixed offset. The offset has to be fixed. Part of the instruction, and the multiplier is also fixed. Unless you mutate the code. You can also mutate the code. Yeah, and it had a hand, because hands, I wanted hands to be the symbol of pointers. Okay. Okay.
So you go to the chicken coop and take an egg. Then you go Croatia, and you steal a dolphin just to visualize memory instructions.
Yeah, the sillier it is, the better. I was thinking how like part of the goal is to make the like most respected and most serious areas of programming childish, you know, to take away all of the, you know, professionalism out of this. Recently I was at a conference and there was a guy there, a crasher. He actually convinced me to move, maybe not move, because he convinced me to make Automat work in the kernel. Like Linux kernel, Windows kernel, just the kernel, like to function as a driver. I think if I can get access to like kernel objects in this totally silly environment, and you know, write assembly and this kind of stuff, I mean, it would be very silly if it's possible to play with kernel structures like that. I'm really looking forward to this. There are just so many things to do.
I'm just saying it could be more efficient. Compre. Yes, it's possible. Mio.
Tadoom says.
I suggest vibe coding the kernel driver.
It's actually not that crazy. I mean, kernel development requires a lot of... So Automat is not going to run in the kernel. It only needs some kind of lightweight ability to react to some events and maybe access memory. Same as, you know, as any debugger. It doesn't really need to exist in the kernel. Kernel is a very limited space. You cannot use... there are plenty of things that are just kind of hard in the kernel. So I think moving like the core of Automat into the kernel is a bad idea, but having the ability to, I don't know, like inject events at the kernel level, like that makes sense. That absolutely makes sense. Like a virtual input device that actually, yeah, it's holding my mouse for me. Give it, okay. It makes sense. It makes sense. And there are also lots of very interesting graph-like structures within the kernel that I think could be visualized better. Like the net filter tables. Net filter tables form like a graph of filters for network packets. They always... I never liked the approach that they offer you, where you have to specify rules after rules.
Automat ex-ebpf.
Yeah, maybe I will have to take a look at eBPF, but eBPF sounds like maybe that could be the way. Not sure. If I remember correctly, eBPF is kind of safe. So it tries to be... It tries to prevent you from doing crazy things. I think we are more interested in some kind of debugger, like kernel debugging interface. This is probably what we would go for. Because eBPF is for kind of a well-behaved extensions. We want to have like the lowest level access to everything. So some kind of kernel debug interface, if it exists, this is the way. I'm actually thinking... Next question is how to combine this effect of pulling. And I guess it's time to start will this work? Kind of works. Okay. I'm not sure I like the fact that the agent has an insight into what I'm looking at. But okay. Say this is fine. Say it's okay. So actually, I will do it differently. I am going to use a VM for this. I have a very nice sandbox for agents. I just need to sign in there. Okay. That's it. Like, the advantage of running an agent on a VM is that here I do not need to worry about permissions. I just say, you have full access. The code is separate from my code, so it shouldn't delete anything. It can delete stuff. Need to be careful. This integration, there is one thing that the Parrot is probably not going to be great at. It's probably not going to animate it very well. So the animation we will have to do, but the plumbing we can do like that. I will actually add a new Commit here. This new clone. Oh yes, I forgot. I wanted it to test it as well, but I hope it will figure this out. Let me try something. If I fire up Emacs, right, it will open in VS inside Automat. What is it called? It's called Pull. For some reason, Alt is not working. I cannot access half of Emacs. Oh no. Key repeat also is not working. I think that's good. I could theoretically edit shaders within Automat, like that. And then if the file on disk changes, I could reload it and reapply the effect. Yeah. This is a glitch when I create a clone. Interesting. And this icon represents the Emacs process. This is the PID. I just put the process on top of the window and can manage them jointly. So silly. I'm actually thinking that maybe I could use the lights, those lights here, show I have entered the window. Oh, this is dead. one more property in this effect I wanted to have, and this is the radius around the center, which is not stretched. Maybe there is no need to do that.
It's Veltrox says,
Yo,
Okay. Maybe I can change the radius of this center somehow cheaply. Yeah, I think doing this lady is the nicest looking example of this effect. When I put this at her feet, they are kind of anchored and she's being pulled. I am going to use this anchor to place it exactly where the pointer is. This way a single point is anchored, everything else is pulled around. Displacement only depends on the distance from the source. It is linear. Being linear is super nice. Maybe do this cube. Let's see. Okay. Now there is a very slight non-linear effect, and we have mirror images, as I thought. Need to normalize it like that. This is a new pull effect that has some better flatness around the source, but this produces mirror images. How many multiplications I can put here? Displacement can be negative, not take square root. One thing I don't like about this version is that I do not control the radius here. It's pulling something. No. Shouldn't square this. Yeah, this standard pulleys are the best. I think I know. That really so. I will just subtract some value from here. And now I have a region of safety, where nothing is pulled. And then it suddenly starts. Maybe this could be fixed. There we go. Now there is a sign pulled in. This is, yeah. Now I can place this dot. The center is not pulled anymore. Only the stuff around this. Actually, I think I could put deer here. Yeah, it's the same code. I want to add some smoothness around this circle. I didn't like that it was so... The boundary is so sudden. Looking through a looking glass. Everything around it is pulled, but it's not what I want. How to make a linear function start smoothly? I think I need to glue like two functions to make it look properly. Okay, so the parrot is testing something. We can take a look and see how it looks here in the emulator. Okay, it's trying to clone the command object. It released it immediately. There is going to be a lot of fine-tuning of constants because that shader toy program was running in UVs. And I think once we move this to metric space, it's going to need some adjustments. Most of this stuff should just scale.
Kadoom says,
Looks good. What are you going to use this for?
Yeah, I can show you. There is this... I will show you a better example. I've just made a simple loop, right? 2 timers. Thing is, I can... Or maybe I can grab one of those timers and I can create a clone of this timer. The clone is different from a copy because clone, it's like in image software. It's like, it's the same object. It's the same object, really. Maybe clone is a bad name, but... my favorite name would be mirror, but mirror is reflection. That would be kind of confusing. So I can grab this object and move it somewhere else to another board, and I will have a magical timer that kind of starts by itself every, half a second or half a second. So this is those are clones. There is a limitation in Automat, deliberate. There is no reason to do this, but I've put this limitation in that when within a single board, an object can have just one location. So when I have a clone here, I drop this, the clone goes back to the one that was already there. I can even create I should be able to create a stack of clones even. So if I clone this one, was that one not updating? The hell?
Essentially, a separate view that allows to modularize. Love it.
Yeah. It's like... It's a very easy way to hide complexity. You kind of can have a board and you can deal with one aspect of the problem on like one board, and you can have another somewhere else, and there you can do, something else. And those clones, they are basically the interface between the 2 parts. Oh, and there is also a rule which says that the conditions are only drawn, the connections are only drawn when both clones are on the same board. See? So now they both will zip in back their own original. It's kind of like in those movies where they can be only one. What was it? Highlander. I think in Highlander they had something like this. It broke the timers. Broke the timer. You have to look at this. Let's run this. Yeah, when the clone flies back while it's running, it gets broken. Will it crash? Yes, it did. Okay. Okay, interesting. So I have this timer. I create a clone. And this clone apparently is now broken. Ignores the limit. How is the parrot doing? Deliver? What? Let's see. I'm not sure I trust it.
am just LARPing as a web dev with Claude.
Everybody is. Have you tried reading the sources that it generates? They look like my code, basically. Like I actually tried looking at the. I will find some file.
URL.
Okay, maybe it's slightly worse than my code. I would never use this for each, and I wouldn't use those expressions.
It loves to add many comments.
Not always, not always. Like, if you do not ask it to code, then it doesn't add any comments. Like, this file, this is an absolute nightmare, you know, the way that it was implemented. But I kind of like this. I think this nightmare is way better than this over-commented graphomaniac pseudo-literate coding that it does normally. If you ask it to visualize something for you, it writes this throwaway code. And this throwaway code, it's much higher quality than the software engineering system within Claude. There are some small things I would kind of nitpick here, but it's generally decent. It's like it did so much logic in so few lines of code. This is actually pretty impressive. Well, those are the sources for this application, by the way. It is actually kind of complex. Okay, let's see our clone. Whoa! Almost correct. But yeah, this is exactly what we wanted.
Trippy.
I'm really surprised it worked. Obviously, the direction is wrong. It should not be the original object being pulled by but my copy. And when my copy is being pulled, I don't think we should draw the original object. I think only this warped image should be drawn then. Let's see how it did it. 0 while resident, blah blah blah, okay. This is nonsense. We have a huge block of code, obviously. Maybe I want to read the shader first. This is a very nice description, actually. It's much better at writing descriptions than me. Mirrors an object along an axis towards the point it's being pulled to. It's nice to have those comments. Actually, those comments can stay. Triple phase in radians. This is a nice idea. This is a nice idea. I would extract more uniforms from here. We'll do this later. Stretch.
Have you noticed any noticeable quality difference in max versus default high effort T-pour?
I never used anything except maximum. I used this hyper code or something like this. They had this thing called hypercode. But it just fired up 10 subagents and just used my old quota, and it was the only time I used it. All of the benchmarks that they are doing, they are when they are benchmarking those models, they are using the max effort. So this is the standard value that they are optimized for. Every other effort level, this is just like a slightly stupider version of the base model. So the maximum is actually the standard value. The default value. It simplified my code so much. Wow, I feel kind of ashamed though. Like, the red stuff, that was my code. The green part is the new simplified one. I mean, I told it to simplify things. I was actually thinking it will simplify the plumbing, not my code. I cannot complain. Zga. Okay, this is a good name. This is not PX. This is never PX. Why is it saying PX here? This is metric. This is very wrong and very confusing name. Or maybe it is PX. I haven't read the plumbing yet. Okay, this axis by gap is the part I fixed here. Here. Origin. This is the strength. Just origin. Constant. And follow this our lip. This is the ellipse formula. Normalized ellipse formula. Normalized and smoothened. Or maybe it moved some of the code out to avoid doing this in per pixel. Anyway, this is excellent. This is excellent. Polarity stays. Drag action HPP.
Trying to vibe up a library for audio analysis, that's a little more modern than the usual stuff shipped today.
That sounds like something that would be interesting to me. Can it draw a Fourier transform, or maybe can it compute the spectrum of a spectrum, like Cepstrum, I think that's the name. Cepstrum? Yes. Or Capestrum. Capestrum. That's the English name. I'm really interested in looking at some of those, but it's such a simple idea, but there are no implementations around.
Right now, I'm just benchmarking a lot of options.
This is the... I'm afraid to look at this, but okay, let's take a look. Drag location widget. Target. Held widgets empty. Okay, so pull is the amount of stretch. We shouldn't do exponential approach. I think we should do... Actually, no, exponential approach sounds good here. Yeah. This is like everybody in game development uses exponential approach for everything. It's rarely the right tool for animation, but in this case we are animating a wind-like effect, so this probably looks better here.
Using Essentia.js as a base, it's a great library and supports so much audio analysis stuff.
I would love to have something kind of graphical, because I really want to kind of see how those things look. Sometimes, just seeing parameters in terminal is not enough to build a mental model. And this draw pull, which already seems fishy. We shouldn't be drawing anything new, we should be warping existing shader.
Oh yeah, it draws live Mel spectrograms with the algo's internal values.
Mel spectrograms. I've heard this word Mel, but what does it mean? Okay, so this is just a regular histogram. Okay. Oh. Usually on a spectrogram you use a logarithmic scale. Mel bands. It sounds like mel spectrogram is just like losing data. Computed, you need the same kind of thing.
URL.
Here, the settings button top left lets you pick.
Let's use a micro. Okay, I do have guitar plugged in, so should be able to see some reasonable values. Is it detecting some BPM? This is not 60 BPM. Okay. Salience, tempo, confidence. Novelty. Interesting. Radio. Okay, if you allow me, I will play with this for a while. As flag settings. Flags is one of the analysis, I guess. That's yeah, it's here. Bass fuse. Oh, this is for detecting bass.
It's probably really broken.
I'm not fast enough to actually see anything higher than 2 onsets per second. Maybe the guitar isn't really counting as bass.
It has a strong dynamic threshold.
I tuned it so low. I think it's around 60 Hz or something like that.
Master Chica says,
How can one prevent DOM scraping?
DOM scraping? Who came up with this name? It's like book reading. How do you prevent book reading?
Kadoom says,
Yeah, the base fuse detector uses 15150 HDs as based or.
Actually, I should be able to check this on my app. What's the frequency that I have on this string? This one should have 100. Why? 131. I feel like it kind of matches my strumming. It's hard to treat above 2 onsets per second. This superflux, this one is very good. Basically, whenever I pull the string, it wakes up. Slightly too sensitive, maybe even. Everything can be tuned. Nice. Yes. Background plot. And oh yes, I can see a spectrogram. It's very faint, but it is here. When I pull a string, you can see those very low resolution lines. This is way too low res. This is... Ooh. Spectrogram 0. This is what we want to see. It looks very fuzzy. Destroy width. Rose. Maximum, of course. Slightly better.
You can increase the rows.
Yeah, that should go up as high as the sample rate allows. Looks so dirty. And a single string so clean. But it's cool that the frequency of this low string is so low that there are gaps in the spectrum. Some things with this spectrogram that I do not understand. And it was good. Gain. Oh, now I see. All of the plots stacked on the spectrogram, they show exactly how the beat detection works. Nice. Nice.
All the code is plain JS, no bundler or stuff like that, so you can actually read it from the browser too.
This is the right way to develop. This is the right way. This is really nice. But you've got to work on those spectrograms. They need to be better. Like, the resolution is so low that it's really hard to read much stuff out of them. And they become very interesting once they become very sharp. Then you can start seeing kind of all sorts of weird things happening here. It's kind of like this picture of the black hole in the center of the galaxy right now. You can just see, a blob. And it needs to be way sharper to see all the detail. Let me compare the linear spectrogram again. Not linear, like regular, logarithmic, with the MEL-based one.
Yeah, it's fun to explore the limits of real-time browser processing too.
You can see those dots? They are appearing and disappearing here. What the hell? When the note is playing. Fun stuff. Fun stuff. Thanks for sharing. Are you doing some music-based game, by the way? It looks like almost like I guess it's going to be used in some interesting way.
Fused. AutoML has a separate fusion combiner for all the detectors choose.
Phase error. Tempo candidates. Oh, this is looking interesting. I have no idea what's the true BPM though. Like, all the detectors, they seem to disagree. Sounds decent.
Meister Chica says,
Worst thing about reporting cheating method is, how the hell do I write this email now?
Tadoom says,
This is what I'm trying to solve, the disagreement. Thankfully, there's a lot of great research and even ML models for this.
The beat detection, it's so strange to me. It feels like an LSTM would do this. You know, you annotate literally a couple music tracks. You try LSTM in some kind of autoregressive mode, like encoder-decoder, and then just teach it on a couple pieces of music, how to detect the beat. And I think it would. And it's very cheap. No, like runs in real time.
It does.
And it should do this almost like very well. It should work very well because beat is such a, I think, basic property in music that it doesn't really require any sort of sophisticated, perceptual. Oh yeah.
There is also a good transformer.
Yeah. Transformer is more for like offline stuff, like you mentioned real time, and for real time, something like a recurrent model would be, I think it would fit better.
Beat this and beaten it through for papers and weights.
Yeah. They probably detect this good, but they are offline. It's not the same thing, offline. And the beat changes during the, music. You notice you even have this like phase error here, right? But those single number doesn't capture this. All I'm trying to say. Okay, let's go back to this. So we have this new function called draw. Yep. Drag location origin. And we build it.
Just thought it was relevant since you're doing shaders and music is a pretty nice thing to visualize.
It is, and this tool looks so sweet. And I do a lot of like rhythm-based games, and for those games you always need some kind of maps, like somebody needs to kind of take a song and manually create a list of, for example, in Beat Saber, right? In Beat Saber. And there are still no amazing tools that would do this automatically. You take a piece of music and create a fun level to play. Yeah, so this is one situation where and DJs also care about this stuff. I play music, but I do not, I'm not at this level where I would worry about BPM alignment.
I see you get it.
Yeah. Something suspicious happening here. Make pointer on. Okay, this kind of works, but this shouldn't really work. Because there are no semaphores created on the GPU. So here we get the widget. Add widgets. We add some random array. It's owned by the pointer. Pointer widget or something? Pointer widget. Oh. Some.
Thanks for checking it out and the suggestion for the spectrogram by Joe.
Yeah, I might be pulling you in in the wrong direction. But yeah, for me in music, like the nicest thing is able to see all those weird things that happen. Like, you know, even when you record yourself speaking and then look at the spectrogram, there's so much funny squiggly lines in our speech. But you have to see them on the spectrogram to notice them.
Some bird calls look really nice too on it.
We'll have to try. I've never checked it. Pointer is probably calling this.
Signal analysis is also cool for inspecting game states. Listen to the audio for clues you'd never get by looking at the screen.
It very much is. Like the game designers, they deliberately put very small. Dark Souls has this, lots of this. You get this, maybe not Dark Souls, but other games similar to Dark Souls. They often play this kind of whoosh effect or something like this to create a reflex, a subconscious reflex, a Pavlovian reflex, to allow you to react faster to some events. Many people, like even like good players, they don't even notice it's there, but it helps them build those reflexes. And it's a simple wave file which is just played back, right? So it's trivial to kind of recognize using Fourier transforms.
That's cool, didn't know that.
Yeah. Sometimes they even tell you that enemy makes kind of a movement before they attack you, and then they play this kind of lots of different effects. Very subtle sometimes. But yeah. And I'm using this on. Okay, I can show you something cool. Like this is mostly kind of experiment. This is experiment, a beta quality thing. But on Linux, there is this audio stack called Pipewire for audio processing. So I can actually grab different objects from Pipewire. This is, for example, my guitar. Gitarka is Polish for guitar. We can theoretically process those audio streams within Automat. Theoretically, because this is like full of bugs, this is just a prototype for how it could look. And the way it looks is honestly awful. Like the way that those nodes are presented should reflect what they really are, like in the memory of the computer. And this window it's a terrible visualization. Yeah, grab Automat. For instance, when I can see this thing moves a little bit, when I pick something up, or delete something. Increase the volume. Yeah. So now Automat can record its own audio, its own output audio. And this pipe, it was possible to drag it. Something must have broken. Anyway.
This project has come so far.
Yeah. But this really needs a lot of attention to... This needs a lot of design before it's usable, really, for anything. But, yeah. It theoretically have some, value. So, in theory, we could combine this with, with assembly so that those values we could hypothetically process in a very fast, like ridiculously low latency fashion by combining those two systems. But again, this needs a proper design.
You probably have some of the highest standards in UI design I've seen.
Standards and, results are different. There are still so many issues. But yeah, I appreciate that you think this way. Pipelines are so hard to design for so many ways. actually pull this out. This and the guitar. Now I can clone it. Wow, it's a stretch guitar. And it should be real time. So when I pull it, yeah, it should animate still.
Meister Chica says,
Does this pass?
URL.
Let's see. So this is, I'm imagining I'm Lichess administrator and I have to deal with cheaters every day. This is like the bane of my existence. First thing, and okay, this is something I actually learned from like professionals. They tell me to always start with your intent, like yeah, who you are, but this regarding, I would convert this to to a cleaner explanation of what your goal here is. So I developed I will get to the point. I just need to read the full thing. Once the analysis is complete, the extension displays the recommended move in the custom UI element. Okay, this is a proper sheet. This is a proper sheet.
You have source coded in Discord. I will remove in the afternoon.
DeepSeek should be good at scraping. This is like a Chinese LLM, right? This is like the state of the art Really.
Actually, you are the admin of the server. You can remove it after you review it.
Let me fire up Discord. Give me a sec. I need to make sure it's in streamer mode or something or whatever. There.
I assume you are not interested in opening book JSON documents.
Really, a cheating extension that injects extension is already at a losing position. Because it's a browser and a website, I think it can ask for the list of installed extensions. And I'm not sure if an extension can really omit itself from such list. It's like a malware that cannot hide itself from the system task manager.
Tadoom says,
Yeah, you gotta instrument the DOM externally. Or use stuff like Violent Monkey Sandbox.
Yeah, the cheating detection goes... the way it typically works is that there are people who attack the websites first. Like on mobile, those are like, they try to kind of follow the protocol. Then there are some integrity checks that verify that, you know, the integrity of the app on the other end. So they kind of escalate to a higher level. They start emulating stuff at the kernel level or like system level. On phones, it's possible to install custom ROMs and do abuse from them. On desktops, it's also easy. Like, you can do this with emulators, you can do this with real hardware.
Meister Chica says,
This thing worked no problems whatsoever.
Yeah, which probably means Leechet has no security. Or like, sorry, not security, no anti-abuse. But yeah, in games, like, there is some kind of contract between players that, you know, kind of the point of the game is to follow some rules, some arbitrary rules. This is kind of the whole point, the definition of the word game. The definition of the word game is that we follow some rules. That's it. That's it. So not following them is kind of, what's the point? What's the point?
B-plug scandal current port.
Amazing, yeah. Okay, I will skip the chess logic, because this is not what I'm good at. I'm also actually not that good at fingerprinting extensions. I just know it's trivial. Read from page data, get game data. Create panel. Yeah. It's... Web worker. Okay. I guess Stockfish is a WebAssembly module. And, analyze and castling. Oh,
Hopefully this one does not get automated.
URL.
okay. How was... Is this the scandal guy?
Demon is Scandal Guy. Here I believe.
Okay, let me jump to how he was discovered. Blah blah blah, public responses. Okay, did they actually found any evidence of cheating?
We want to know for sure if that actually happened.
I feel like they could solve the cheating problem the same way that streamers kind of solve this by just delaying the stream, you know, so that any sort of like video transmission or something like that of the game is going to be delayed. Especially in like games like Blitz. Okay, what can I say? Like, the bar is very low for detecting this kind of cheat. It's like the most simple, the most trivial anti-cheat is going to detect it right away. Like, you literally look at the list of extensions and you see Lee cheat in this list. Like, this type of cheat can be discovered by running regex for cheat in memory, and it's there. Yeah. I think their strategy is that they detect this kind of stuff, but maybe they do detect it with a delay. Like, part of the good anti-abuse strategy is to not reveal your cards, so the anti-cheat engine may not be really trying everything right away. It may be checking you, you know, maybe once per 10 games or something like that, if you are cheating. Randomly, you know, to never reveal. And even if it detects you, it will probably let you play for another couple of days before they ban you, so that you do not get any immediate feedback. This is like, this type of mind games is the foundation of anti-abuse. It's a psychological warfare, really. It's more than technical. The point of anti-abuse is to discourage the attacker, not to, you know, outpower him. Because if somebody has enough time and motivation, they will continue doing stuff like that.
Yeah, but that is my implementation. Imagine what actually guys who sell the cheats for life do. Funny thing is, it was not detected until it was used in rare tournament on Leicester.
That actually makes a lot of sense. Like, they probably do not want to leak their anti-abuse signals, you know, when people just play regular games, only when there is actual stakes involved. They deploy this. Yeah. Yeah. Those tournament games, they sound like the weakness of leeches. This is probably how their infrastructure could be fingerprinted. Their anti-abuse infrastructure, I mean. How they collect signals and what signals they collect. Yeah, because they blocked you during this rated tournament. Now you know that you can just, you know, during a rated tournament, you should not worry about cheating. Then you should worry about like fingerprinting the anti-abuse system, how it works, what it does. Yeah, first line is important in emails. Like, it's a very nice close. Okay, I wanted to tweak this. Actually, I didn't want to tweak this. I still want to understand why the hell it works. Okay, we have this widget called object, which is totally wrong. It's not how it should be called. I'm trying to understand. Okay, so this is a miracle that it works. There is no synchronization inserted anywhere. And there is this awful naming issue. I need to actually put this all in writing so I don't forget. Okay, so there is this. I know why the pull direction is wrong. It's because of this property, location widget. should not be here. Why is this? Okay. Oof. It's going to be tricky to untangle this, but I think it should be possible. This is not exactly... Yeah. Name of this? They really like this? Or was it some... Okay. Use mortal PR when it helps. And the comment here should be that this should be removed. We are using pixel. This is a small round for feedback. And those pixels, I don't think it's that bad. It's probably alright. I will put all of those changes. This is part of documentation. I don't think I need to review this. This should really be reverted. This is wrong. This effect actually looks very nice here. And the object is clipped. We only see part of it. Right. Not sure if you can see this. I think it's fine. Probably alright. Actually, no. Actually, yes. This is fine. This is totally fine.
Why is mx.google.com blocking sending source code? It's plain text FFS Ashtual.
It'd be very strange for like mail to block source code.
Tadoom says,
It looks very sussy to the model checking it.
Cloning a macro recorder is tricky because they behave differently, but this is still the same object. Like two copies of this macro recorder. Not like this effect. it works surprisingly well. I'll add some animations in a second, but first the direction has to be fixed. So strange, and what I did? Oh, no. Oh, and both of them are drawn like that. Interesting.
Meister Chica says,
It's blocking JavaScript script only like F Google.
I guess everybody's exchanging GitHub links nowadays.
They ship load of JS a day, and you can send 30 kpb of JS in that.
I would actually be suspicious I couldn't send a JS. Let me check something. Compose a quick email. Me to my other account. I will download your JavaScript event, see if it passes. Do you want me to delete it, by the way? There were errors with attaching your files. What? You actually cannot send JavaScript. I just checked it.
Yup, nuke it.
Probably here, yes. Blah blah blah. Okay. Blocked for security reasons. Interesting. Some security scanner actually detected this somehow as malicious code.
I got reference to this page. It's in Croatian.
URL.
Stuff. This is an emulator. It's running Automat. I do not see this effect anywhere. I was anyway surprised that it worked on first attempt.
And I'm not sharing it as Google Drive document. any other way to prevent random discovery.
The only way is to call them in person and to recite the JavaScript over telephone. This is like the only way to not get sniffed.
Padoon says,
Don't be sus.
Meister Chica says,
What is translated to Morse code and send that?
Padoon says,
Try RFC 149 to Washington.
Meister Chica says,
I removed .js and it got sent.
Nice. This is a very interesting security scanner. Maybe it's just making sure people do not do... Actually, I do not know what. There is always a reason for those things. There is always a reason. It's too specific to be an accident.
Padoon says,
Probably because Dace files can be executed on Windows.
What? Can they? Ah. Had no idea. It kind of sounds nice, actually, if you think about this. It would be nice if Windows supported JavaScript as a scripting language. You know, if you could access Win32 APIs through JavaScript. That would be fun. Without Node, because in Node.js, yeah, you can do this. Okay, I see code deleted, that's nice. Actually, those incoming flights, that was the whole point, to show some external object being pulled in. We're going to see the test. Still debugging something. What is it doing? Okay. It was our clone. It was there for a second. Okay, it functioned nicely. You know what? Stream is getting kind of longish. I will cut it here now. I will finish this afterwards. Everybody's got to eat, right? Right. So on the next stream, I expect this will already be in place. So we will start working on something new. Maybe we can try thinking about this problem of this optimization problem. I really would like to design some like system of quickly designing low-level optimization search of system. Yeah, we'll see. Or maybe I will change my idea, who knows. Or maybe we'll do some music analysis on Wednesday. We will see. Anyway. See you next time. Bye-bye.
See you around.